right, this is section 11.1, inverse functions. There is a typo on your stamp sheet. That should say 659. Please change that on your stamp sheet. Angela didn't do it. 659 to 662. The first three questions are vocabulary. I need you to be able to tell me the difference between an inverse function and something that is invertible. What is a convertible car, Sophia? How do you know something's a convertible? What does it have that no other cars have? You're not sure? Have you ever been in a convertible car before? I'm sorry? You're not sure? Cesar, what's a convertible?
It's like where the hood can come off.
Yeah, the top goes down, Sophia. So it's like that whole top part converts, and now it's a convertible. That means it now no longer has a roof. We're going to talk about something that's invertible. That means it has an inverse. Okay? All right. So those are the three words that we're going to be going over today. Let's go back to math 1. First of all, how do we know if something's even a function? By definition, a function is for every input, there is exactly and only one output. That's by definition. So, if you have a table, that would mean that your x's would be different and each one of these are different. For every input, there's a different output. This is a definition of a function. So you'll notice each x has a different y. It's not like this 2 has a 10 and the 1 has a 10. They have different values. So this would be an example of a function. Sometimes I feel like it's easier if you tell me, well, what's not a function? This is something that's not a function. Something like this. You'll notice that 320 is in the graph and so is 325. That's not okay because the 3 has a 20 and the 3 has a 25. That's two different values for the same x. So if your x's repeat, essentially, that means it's not a function. So a good note to have to yourself, it's not a function if the x repeats with a different y. That's layman's terms, okay? That's like for me and you to understand. But the real definition is explained on the top. For every input, there's exactly and only one output. So since you have 3 here, that goes 320 and 325, that means when you graphed it, that means you plotted a point at 320 and at 325. That's not a graph. That's not a function. So let's see how that would look on a graph. So graphically, that means that if I were to plot these points for the function, let's go ahead and plot the same points that we created. So if I have 0, 1, 2, 3, and here I have 5, 10, 15, 20. If I were to plot these points for a function, 0, 5, 1, 10, 2, 15, 3, 20, you'll notice that the x values do not repeat. So I didn't say 320 and then 325. Use your highlighters, please. I have my 3 degrees. I already know this. Now I need you to do that. What would it look like if it's not a function? Five, 10, 15, 20, 25, 0, 1, 2, 3. Five, 10, let me mark these off. 2 is at 15. 3 is at 20, and 3 is also at 25. So it's a straight line, and then it goes straight up. Oops, pardon me. Notice that you have one x value that gave you 2 different y values. So this one is not a function. So instead of investigating each and every single point, there's a way for us to test every graph, and I'm sure you've heard this before. Raise your hand if you remember. There is a way to test a graph easily and see if it's a function. Who remembers? 1, 2, 3, 4, 5, 6, 7. Anybody in table 5 remember? So here, how? There's something called a vertical line test, right? So that means I put my pen down vertically, which is what I want you to do. And you'll notice that if my pen hits 2 points at the same exact time, it has failed the vertical line test, which means it is not a function. Samantha, I need you. Sophia, I need you. Ready? I know you're writing, but I want you to watch this. If I take my pen and run it across my function, and it hits my pen twice at the same instance, which means for every x value there's a multiple incidence, then it is no longer a function. If it passes my pen more than once, which it does right here, doesn't it hit my pen twice right here at 3? Then it is not a function, because now my y values have repeated. Let's do an example. Example 1. Is this a function? There's a couple of ways that I can identify this. If I imagine x values here, do any of my x values have more than one y value? Yeah, how about a lot of them? Like this x value right here at 0, it has 2 answers. Do you see that? So if I were to do the vertical line test, it fails here, 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 all the way through. So if I asked you, is this a function, would the answer be yes or no? Why not? Because it fails the vertical line test. It's enough. So this would be a no because it fails the vertical. You guys, vertical is C-A-L, by the way. Some of you guys are still spelling it C-L-E. Vertical line test. How about this one, example 2? Is this a function, yes or no?
Yeah.
I haven't drawn it yet.
Oh, I thought it was that thing right there.
You're right. It does look like it's that one. It's all good. If you had to wager an answer, please raise your hand when you think you have an answer, whether this is a function or not. I should see people doing this instead of just staring at me. Do this. Dylan, what do you think, babe? Not a function because it fails the vertical line test right here. Right here. Right here. Everybody see that? This x value, no matter what it is, has too many y values. How many is it allowed to have? One. So this is not a function. And Dylan's being nice because he says the words, does not pass the vertical line test. Sorry, I said the word fails. Fails. You could put it either way. Let's be nice. Does not pass. Does not pass the vertical, sorry about that, line test. Here's your doyo. Is this a function? Nah, dude. Organize that table for me, please, because it's all over the place. Alana, what do you think?
No.
It is not? Where does it fail the vertical line test?
Yeah.
Where then? Here? Okay, so I'm really glad you brought this up. So do you see how it's not doing this? That is doing this. So it's kind of curving out to the side. So it's a little bit tricky. So you think it's going straight down. But do you see how this is not exactly going straight down? It's actually getting curved like that. So this one's actually a function. It is. Okay, so this one is a yes because it passes the vertical line test. Can you please put those stamp sheets and greeting cards in that bag, please? I need to also put one of the water bottles in. All right, example 3 on tonight's homework is I need to draw the inverse of a function. No, there's a bag. This bag. So another property of a function that has an inverse, and we're going to go over it all week long, but something that has an inverse means this right here. So if I give you a function f of x, then the property of its inverse, which is written like this, the table of its inverse is very simple. You switch the x's and the y's. So since this is the x's and the y's in the original function, its inverse is going to have its opposite or switched points. So if 0, 1 exists in f of x, if you were to graph 0, 1, on the inverse, you're going to graph 1, 0. If 1, 5 exists in the graph, then it's 5, 1 on its inverse, and so on and so forth. 8, 2, 9, 3, and then 15, 4. I'm just going to put dot, dot, dot so that you can see that it continues. So what we do here is you're switching your x's and your y's. Tonight's homework, I'm going to give you a graph and I'm going to ask you to graph its inverse. Tomorrow we're going to go into much more detail as to what the inverse is and what it does. But today let's just become familiar with it and just learn how to manipulate it. Tomorrow we're going to get into dive into why we're doing this. So what you're going to see on tonight's homework, example 4, is you'll see something like this. They'll tell you that f of x is equal to negative x squared, for example. And then they want you to graph the inverse. Remember, when you have this little negative 1 right here, that's the inverse. So what do you think I have to create first before I can create the inverse? What do I need? I need that table, right? I need a table for the function, and then how am I going to create the inverse from the function? What am I going to do with the points? I'm going to switch them. So first I need this. Now, I don't know why last year my kids were like, oh, what points, who cares what points you use? It doesn't matter. I could use 0, 1, 2, 3, 4. You could use 2, 4, 6, 8, 10. Somebody else could use negative 5, 4, negative 4. Who cares? You're going to graph the same graph. Okay? But for simplicity's sake, because of the way your graph is on your paper, you don't want to use huge numbers. So let's agree to use these Fab 5. Let's agree to use negative 2, negative 1, 0, 1, and 2. And then this will be your f of x. And then we'll graph the inverse on this side. All right, where did my kids mess up the most? Right here, plugging it in. They would plug it in wrong. They would forget, please excuse my dear Aunt Sally, and forget when to make it negative and when do you exponent first, and I just don't want that to be you, okay? You get to use a scientific calculator, but make sure you're plugging it in correctly. So negative 2, plugging it into the equation, remember the equation is negative x squared. That means you square it first, then make it opposite. You square the number first, then make it opposite. Cesar, help me out, babe. Ready? What's negative 2 squared? We're plugging this in. What's negative 2 times negative 2? Positive 4. Now make it opposite. Thank you. Negative 4. El otro Cesar. Ready? Plug in negative 1. What's negative 1 squared?
Oh, that's 2.
Careful. What's negative 1 times negative 1? 1. Now make it opposite. Thank you. Kirsten, plug in 0. What's 0 squared?
0.
Now make it opposite. 0. Good job. Isaiah, plug in 1. What's 1 squared?
1.
Now make it opposite. Thank you. Heidi, plug in 2. What's 2 squared? 4. Now make it opposite. Negative 4. Now am I going to plot these points? That's what they want me to do? To plot the function? No, what do they want? Plot the inverse. Well, how am I going to plot the inverse? What do I need to do? Switch your x's and your y's. Kanoa, what's the first point right here? -4, -2. Then I'm going to do -1, -1. Then I'm going to do 0, 0. Then I'm going to do -1, 1. Then I'm going to do -4, 2. Kyle, fight it or stand up? Kathleen, can you take a guess whether or not the inverse is a function or not? Why? Very good. How come it's not a function?
There's two of these.
Very good. We got -4 goes to -2, and -4 also goes to 2. Are we allowed to have two different values? No. So it's not a function. But that doesn't mean it's not graphable. Hello. An inverse doesn't have to exist in order for you to have a graph. So some people, last year's homework, I don't know why, they're like, oh, it's not a function, you can't graph it. Huh? You can still graph it. It's just not a function. So now these are the points that I'm going to graph on my inverse. So that means I need to plot -4, -1, 0, and then -1 and -4. So we're literally only on the left side. Do you guys see that? Do you guys see how these x values are only on this side? So here's your 0. Here's -1 and -4. Those are the only x's that you have. So it's -4, -2, -1, -1, 0, 0, -1, 1, and then -4, 2. Brooklyn, how can I tell this is not a function by the graph? It does not pass the vertical line test. So Kathleen was able to identify automatically by its table that the x's repeat with different y values, not a function. How can you check? Graph it. Fails the vertical line test, not a function. What do you guys think? Doable? Questions on example 4? Can you try a doyo, please? F of x is equal to -x cubed. Graph f of the inverse.